Hello, and welcome to this short video talking through how to add and subtract algebraic expressions. In this video I'm just going to look at those expressions with numerical denominators, so where we have numbers on the bottom of our fractions. Before I get into the algebra, I think it's important to just recap how we go about adding normal fractions. So if I have 2/3 add a quarter, the key thing about this is I can't add them until they share a common denominator. So in this particular example, I'm thinking, well, what's the lowest common multiple of 3 and 4? And the answer for that is 12. So I would rewrite this as 2 fractions over 12 added together and think, how has that 3 changed to become this 12? I've timesed it by 4. Well, it's got to be an equivalent fraction, so I'm timesing the top also by 4, so 2 would become 8. And then I'd look at my second fraction and think, well, how does my denominator of 4 become 12? I've timesed it by 3. So the numerator would also have to be timesed by 3. 1 times 3 is 3. And once we have a common denominator, we end up adding the tops, but our denominators stay the same. So in this particular example, we'd end up with 11/12. Okay, and the same approach can be said when we're subtracting fractions. The key thing is to first make sure we have a common denominator. So this time we would have 8/12 minus 3/12, and this would end up with being 5/12. Okay. Now I'm going to use this idea and try and bring it into a few examples with algebra. So here you can see I have the same denominators, so we know I'm going to have 1 fraction over 12 add another fraction over 12, and just follow the same patterns I did before. I've times the 3 by 4, so I have to times the numerator also by 4 to keep it as an equivalent fraction. So a times 4 is 4a. Okay, and over here we've times the 4 by 3 to get 12, so I need to times the numerator b by 3, which gives me 3b. I'm going to start working mathematically now in a column, so we would combine our denominators. They stay the same, they don't get added together. If you're wondering why, if you think about a half, add a half is a whole. Well, if you added the tops and the bottoms, you'd end up with 2/4, which is still actually a half. Whereas if we just added the numerators, we'd get 2/2, which is a whole. Okay, so remember, when we're adding or subtracting fractions, we need the denominator to be the same, but we don't add them together, it stays that value. So we've got 4a add 3b, and at this stage we think, well, can we collect any of the terms? And in this particular example we can't, because we've got a's and b's. It's like having apples and pears. We can't quite, we can't combine those terms. Okay, let's have a look at my next example. So this would be my final answer. Okay, so here I've got 2x over 3 minus x over 6. Now, I don't know if you noticed, but in our last example, we actually ended up multiplying the right-hand fraction by our left-hand denominator, because it just so happened that the lowest common multiple was the result of 3 times 4. Okay, and this will always be the case. You'll always have a common denominator by multiplying your two denominators together. So if you're stuck trying to find this, you could always times the right-hand fraction by the left-hand denominator and vice versa. However, in this next example, I can take a slight shortcut. So rather than timesing this whole fraction by 6 and this whole fraction by 3, I could say, well, the lowest common multiple of 3 and 6 is just 6. So I only need to multiply the left-hand fraction by 2 over 2. So 3 would become 6, and 2x times 2 would become 4x. Okay, now my right hand fraction is already over 6, so I can leave it as it is. And so we end up with 4x minus x all over 6. And this time we do have common terms, so we can collect these terms. We have 3x now over 6. And at this stage, are we done? Well, we should always check our fraction and think, well, can this be simplified? Well, the 3 and the 6 in this particular case can be cancelled. So if I cancel this, 3 goes into both of these. It goes once into 3 and twice into 6. So this ends up being 1 times x, or just x, over 2 as my final answer. Let's just highlight that. Okay. Last or penultimate example, I'm not sure. No, it is my last example. There we go. We have 2x plus 1 over 5 minus x minus 1 over 7. This is a little bit tricky. Lowest common multiple between 5 and 7 is actually when we multiply them together. So I'm going to take this numerator and multiply it by the 7 to make 35 on the bottom over here. And I'm going to take this numerator and times it by the 5 to make 35 on this denominator. Now, rather than try and do it all in one go, I think it's important that we just leave our steps, incrementing bit by bit so that we can see what's going on. So I'm going to start off by just leaving this in brackets and saying, well, I'm going to times this by 7. I'll show you what I mean now. So they're both going to be over 35. Okay, and we're taking the left-hand fraction, and this has been multiplied by 7, the denominator of the right-hand fraction. So it's going to be 7 times 2x plus 1. I know a lot of you could probably expand this out straight away, but I'm going to leave it like that for now, and hopefully you'll see why in a second. And the right-hand fraction, can you think what it would be? Yeah, it would be 5 times x minus 1. Okay, and then I'm going to keep them in their brackets, but now I'm going to combine them into one fraction over 35. So this is 7 times 2x plus 1 minus 5x minus 1. Now some of you might be seeing why I've left it in brackets at this stage. What we have when we expand this out, our first bracket will become 14x times, and then 7 times 1 plus 7. I'll just do my denominator so that it's clear that everything's over 35. But for my second expansion of brackets, it's important to remember that this is minus 5 in front of the bracket. So I've got minus 5 times x, which is minus 5x. But I've also got minus 5 times minus 1, which will become a plus 5. This is the most common mistake that generally gets made, people forgetting that if you've got a negative in front of that second bracket, it's going to affect both terms within that bracket. So a negative times a negative is going to give me my plus 5. And now I can start simplifying. Okay, so 14x minus 5x is 9x. And 7 add 5 is going to be 12 over 35. Now you could even go one step further and start simplifying the top. You could take a factor of 3 out of there and say that this is 3 times 3x plus 4, just to see if anything will cancel from top and bottom, but in this particular case 3 does not go into 35, so it can't be simplified any further. Okay, I hope that helps. In the next video I'll start looking at how to add and subtract some algebraic fractions, but this time when we have algebraic denominators instead. I hope you find that helpful.